Hello children, in a previous class of measurements and experimentations, we discussed the concepts of unit A. As I told you that there are 3 units, we could complete only unit A only. So in that unit A children, we discussed what actually measurement is, what is a physical quantity, and how can we express the physical quantity, and there we discuss what is a unit and its parameters and the types of units, and after that we discussed different types of system of units. There we discussed about MK system, CJ system and even SI system. Of course, FPS also we discussed, and after that we discussed about the units of length, mass, time. So there we discussed in detail what are the metric units, and even we discussed about non-metric units of mass, length, time also. And finally we could discuss what are the guidelines, like how can we write the units. So what are the rules which we should follow in order to write the units which we discuss. In today's session we are going to discuss the exercise 1A. So in this session we are going to cover all questions, I mean conceptual questions, and even if possible we will try to cover even numericals also. So dear children, then what you have to do, just pause the video, get a notebook and a pen so that you can write the answers even when we are discussing. My name is Naresh, welcome to our channel Physics Plaza. So children, question number 1. So even you can see the question on the screen also. First question, what is meant by measurement? Children, the process of comparison of unknown quantity with known standard quantity of same nature is called measurement. I repeat once, the process of comparison with unknown quantity, try to understand, unknown quantity with known standard quantity of same nature is called measurement. Question number 2, what do you understand by the term unit? So children, unit is actually what? Standard known quantity. For suppose if you want to measure the height of the person, actually his height is unknown quantity. So you are going to use, for example, meter. So this meter is what, children? Known standard quantity. And here one more thing also which we have to remember, very important. Height is length only, meter also length only. So both are same nature. So how can we define unit? So it is a known standard quantity which is used to measure the unknown quantity of same nature. I repeat once. Unit is a standard known quantity used to measure any physical quantity of same nature is called actually unit. Question number 3. What are the 3 requirements for selecting a unit of a physical quantity? Children, of course we have 4 requirements which we have, but in question asked only 3 only. So what is the first one, dear children? Just note down. The first one is, unit means it should be defined without ambiguity. It should be defined without ambiguity, first one. And the second one, it should be of convenient in size. It should be convenient in size. And third one, it should not change with space and time. It should not change with the space and time. So these are the 3. As they asked only 3, just we will be writing only 3 requirements. Fourth one, name the 3 fundamental quantities. So that is third one which we discussed, and fourth one is name the 3 fundamental quantities. Of course, dear children, we have 7 fundamental quantities, but they are asking 3 only. What can you write? You can write length, mass, time. Of course, it is not compulsory to write only length, mass, time, because these are the fundamental quantity which we measure in other 3 system of units also. That's what we are going for, these 3. Otherwise, you can go for electric current, thermodynamic temperature, amount of matter, and the intensity of light. You can go for that also even. Okay children, fine. Now moving to question number 5. Name the 3 system of units and state the various fundamental units in them. So children, 3 system of units means we have MS system which we have. So in MK system, dear children, so it's one more very important thing is that first letter represents length. It represents actually length. Second one is mass. So as usual, third one is time only. Third one is time. So here as they asked, so in MK system, mass is measured in meter, length is measured in meter, mass is measured in kilogram, time is measured in second. Whereas in CG system, length is measured in centimeter, mass is measured in gram, time is measured in second. Whereas in FPS system, dear children, length is measured in foot and mass is measured in pound, time is measured in second. So these are the three system of units and how we can measure even length, mass, time. Okay, fine. Now moving to question number 6. Define a fundamental unit. Define a fundamental unit. So what is a fundamental unit, dear children? The unit which do not depend on other units. It's very important. Or else we can define like this also. The unit which is not derived from other units is called fundamental units. Children, can you give the examples of fundamental units? Just you can pause the video and you can comment the answer. Give example, at least one example for fundamental unit, one example for fundamental units. Just pause the video, think and comment the answer. Okay, fine. Moving to next question. Question number 7. What are the fundamental units in SI system? Name them along with their symbols. Name them along with their symbols. Even dear children, you can see the answer on screen also. So there are 7 fundamental quantities as I told you that. What is the first one? Length, mass, time, electric current, thermodynamic temperature and amount of matter and intensity of light. These are 4 are there. So what are the units of course in SI system, mass is kg, okay, length is meter, time is second, electric current is ampere, thermodynamic temperature Kelvin, amount of matter mole. Children, you must be very careful. Unit is MOLE, but symbol is MOL only. And the last one, intensity of light, is a candela. So these are the 7 fundamental quantities and their units. Even you can see on the screen also. Next, question number 8. Explain the meaning of derived unit with the help of one example. So children, already we discussed, it's a question number 8, dear children. Question number 8. What is, like they are asking us to define the derived unit. Define the derived unit. Children, what is a fundamental unit? I told you that, which is not depending on other units. Derived unit, the name itself will give you the concept. Derived means what? It can be derived from fundamental units. So the unit which is dependent on other units or which is derived from other units is called derived unit. So let me give you one example, simple example. Dear children, for example, the SI unit of force. SI unit of force. So we know that SI unit of force is Newton. SI unit of force is Newton. Children, can we write like this? No, we should not write like that. It is wrong. Why? Already we discussed, whenever we are writing the full name of the unit, it might be named after scientist or not. First letter must be small only. So, okay, this should be small n, Newton. Now it is right. So we know that Newton is a derived unit. But how can we say that it is a derived unit? On which fundamental units does it depend? So children, so from the a mathematical form of Newton's, what we can say, force, F is equal to ma. So we know that force is equal to actually mass into acceleration. But anyhow, mass is a fundamental quantity. Acceleration means, how can we write it, children? Velocity by time. That is velocity by time. And let us check once again. Here mass and time are fundamental quantities, no problem at all. But velocity is not a fundamental quantity. Again, it should be written in terms of displacement. So here velocity is equal to what, children? Displacement by time. Displacement is nothing but length only. So we can write directly length by time. So it is length by time by it is time only. So let us write it is a mass only. Now this time you come to the denominator. Time into time, it will be time square. So it will be, just look into it now. Mass is a fundamental quantity, length is a fundamental quantity, time also fundamental quantity. Now let us write the units of these fundamental quantities. So what do you get here? Kg meter per second square. This kg meter per second square we can call it as a Newton, that's it. So Newton is a derived quantity, derived unit. It can be expressed in terms of fundamental units. Those are kg meter second. Okay, just copy it. Now moving to question number 9. Define the standard meter. Children, first of all, what meter is a SI unit of length. SI unit of length is a meter. But how to define? Children, this meter is defined actually in terms of the light. Means we all know that light can travel 3 lakhs kilometers in 1 second. 3 lakhs kilometers in 1 second. So how can we define? So even it is, the meter is defined as the distance traveled by the light through a vacuum in 1 by seconds. So what is a meter? The length of the path traveled by the light in 1 by this much in seconds. So it is a negligible, right? So the distance traveled, we know that light can travel in 1 second. What is the distance traveled with the light in 1 second? 3 lakhs kilometers. But the length of the path traveled with the light in this much time is equivalent to the 1 meter. Fine. Next, moving to question number 10. Name 2 units of length which are bigger than meter and how they are related to the meter. So bigger than meter, children. So we have AU, that is astronomical unit, is equal to 1.496 into 10 power 11 meters. Is the first one. And whereas second one, children, light year also we can take. Light year. Children, don't get confused. Of course, year is a unit of time, but it's a light year is a unit of distance, which is equal to 9.46 into 10 to the power of 15 meters. Okay, fine. Moving to question number 11. Write the names of 2 units of length smaller than a meter and express the relationship with a meter. Children, in 10th question they asked bigger units than meter. Now smaller unit they are asking. Let us say angstrom. 1 angstrom is equal to 10 power minus 10 meters. The first one. And the second one is, let us say Fermi. So 1 Fermi equal to 10 to the power of minus 15 meters. Now question number 12. How is nanometer related to angstrom? Children, it's very how is nanometer related to angstrom? Question number 12. First you think, what is the angstrom? We know that, dear children, 1 angstrom is equal to 10 to the power of minus 10 meters. Yes or no? Yes. Now can I express this 10 power minus 10 like this? 10 power minus 1 into 10 power minus 10 meters? Of course we can. But what is this? Nano. This we cannot completely nano. 10 power minus 9 is a nano, dear children. So 10 power minus 9 meter is a nanometer. So 1 angstrom is equal to this 10 power minus 1, I can write as a 1 by 10. It is 1 by 10 nanometer. So 1 angstrom is equal to 1 by 10, that is 0.1 nanometer, or get this 10 this side. So it will be 1 nanometer is equal to 10 angstrom. Children, it's very important. 1 nanometer is equal to 10 angstrom. Just copy it. Now we will moving to question number 13. Children, question number 13. Name the 3 convenient units used to measure the length ranging from very short to very long value. How are they related to the SI unit? Children, first you should think, what is the SI unit of length? Is a meter. So now you have to think smaller to bigger, they are saying smaller to bigger. So it is question number 13. Question number 13. So very smaller means, of course we have many. Let us take a Fermi only. So here Fermi, smaller one. So how is it related to the SI unit of meter? 10 power minus 15 meters. Okay, fine. Next, let us go for angstrom. 1 angstrom is equal to 10 power minus 10 meters. Now, third one, let us go for 1 micrometer. 1 micrometer is equal to 10 power minus 6 meters. Still we are going for smaller to big. Now fourth one, let us take a 1 millimeter will be 10 power minus 3 meters, and the fifth one let us go for 1 kilometer is equal to 10 power 3 meters, and let us go for one more also. We can take a light year. So here light year is equal to 9.46 into 10 to the power of 15 meters. Actually they asked us to write 3 only, but let us learn extra also. So this is a smaller to big, copy it. Now question number 14. So what is the SI unit of mass? So the SI unit of mass is kg only. Now question number 15, dear children, complete the following ones. So question number 15, complete the following ones. First one, 1 light year is equal to how many meters? 1 light year is equal to 9.46 into 10 to the power of 15 meters. Second one, dear children, 1 meter is equal to how many angstroms? Children, 1 angstrom is equal to 10 power minus 10 meters, but 1 meter is equal, they are asking. 1 meter is equal to 10 power, what we can say, 10 angstrom. Can you write like this? So of course we can write. So 1 angstrom is equal to 10 power minus 10 meters, but 1 meter is equal to, obviously it is a 10 power 10 angstrom only. Sorry, these all are A, B, C, D is given. It is A, B, C and D. 15th one, D, dear children. 1 micron is equal to how many angstroms? First let us write 1 micron is equal to. Children, here 1 micron, that is micron is micrometer. It is 10 power minus 6 meter. 10 power minus 6 meter. So what can we write this? So this can we write like this? Multiplying with the 10 power 4 like a 10 power minus 4. Look at here. What we are doing? Just anyhow, this value is again 1 only, dear children. Nothing makes different. 10 power 4 into 10 power minus 4. Its value is 1 only. This 1 only. So what we will do? Just think about this. 10 power minus 4 into 10 power minus 6. So it will be 10 power 4 into 10 power minus 10 meter. Children, this 10 power minus 10 meter only equal to 1 angstrom. So here it is 1 micron. 1 micron is equal to 10 to the power of 4 angstrom. 1 micron is equal to 10 to the power of 4 angstrom. Just copy it. In 15th question only we have last one, that is 1 Fermi is equal to, of course already just we discussed, 1 Fermi E is equal to E. 15th E, 1 Fermi is equal to 10 to the power of minus 15 meters. 10 to the power of minus 15 meters. So with this we could complete question number 15. Children, moving to question number 16. State 2 units of mass smaller than kilogram. How are they related to the kilogram? So 16th one, they are asking the units which should be less than, smaller than the kg. So smaller than the kg means you can take AMU. Okay, 1 AMU is equal to 1.66 approximately into 10 to the power of minus 27 kg. Minus 27 kg. So second one means let us take a milligram. Milligram also you can take. 1 milligram is equal to 10 to the power of minus 3. 10 power minus 6 kg. They are asking us to write in kg, right? 10 power minus 6 kg. Now moving to question number 17. State 2 units of mass bigger than kilogram. Give the relationship with kg only. First one, let us go bigger. Let us take a solar mass. Solar mass. Children, solar mass equal to 2 into 10 power 30 kg. You can write. Okay, now. And the next one, second one, you can go for quintal. Children, quintal is equal to 100 kg. So these are the bigger units. Children, these two are the smaller than kg, they are the bigger than kg, and how they are related to the kg. Now moving to question number 18, dear children. Moving to question number 18. So it is also complete the following ones. Children, here 18th question, and in this 18th question again we have A, B, C, D. So what is the first one? A, they are asking 1 gram is equal to how many kg? Children, we know that 1 kg is equal to 10 power 3 gram, that is 1000 grams. So 1 gram is equal to, get this 10 power 3 this side, it will become 1 by 10 power 3. So it is 1 by 10 power 3 kg, or even you can write 10 power minus 3 kg, that is the A. Next B, 1 milligram is equal to how many kg they are asking. Children, 1 milligram. Children, milli is equal to 10 power minus 3. So it is 10 power minus 3 into. Children, gram is equal to, just now we got 10 power minus 3 kg. So in the place of gram, you can substitute 10 power minus 3 kg. So it will be 10 power minus 3 kg. So 10 power minus 3 into 10 power minus 3 will be 10 power minus 6 it will be. So 1 milligram is equal to 10 power minus 6 kg. Now see, 1 quintal is equal to how many kg? Of course, it is a direct one. So 1 quintal they asked. 1 quintal is equal to 100 kg. 1 quintal is equal to 100 kg. Next D. 1 AMU is equal to 1 AMU is equal to 1.66 into 10 to the power of minus 27 kg. Children, what is AMU? What is AMU? Children, it is defined as what in terms of carbon. C612 will define. Means it is like 1 by 12th of the mass of the C612 is equal to the 1 AMU, that is equal to 1.66 into 10 to the power of minus 27 kg. Now children, question number 19. Question number 19. Name the SI unit of time and define it. What is the SI unit of time, dear children? The SI unit of time is second only. Children, whether you can go for SI unit, MK, CGS, FES, whatever may be the system, the unit of time is second only. Question number 20. Name two units of time bigger than a second. How are they related to the second? So children, question number 20. Bigger than second means you can take a minute, hour, year, anything you can take. So let us take first one, minute. 1 minute is equal to, you can write 60 seconds. Second one, let us take a year. So 1 year is equal to approximately 3.15 into 10 to the power of 7 seconds. It's approximately we are writing. Okay, fine. Question number 21. What is a leap year, dear children? What is a leap year? So the year, obviously in which you will get 29 days in February actually. Means generally for a normal year means 365 days we will be having, but a leap year will be having 366. So how to decide whether it is given one is a leap year or not? Just you have to divide with a 4 table. That's it. Yeah, that is the 21st question. And 22. Here one statement is given. They are asking whether it is true or false. The year 2020 will have February of 29 days. Is the statement true? Of course, obviously it is a true only. As I told you that we can check with the 4 table. Now 23rd question. What is a lunar month? What is a lunar month? Dear children, so we all know that moon will be revolving around the earth. So the average time taken by that moon to complete one revolution only we can call it as a lunar month. Now 24th question. Complete the following ones. Again here we have A, B, C, D. So let us do that. A, B, C, D. First let me rub this. Question number 24. Question number 24. A. 1 nanosecond is equal to how many seconds? Children, 1 nanosecond. Children, nano is a prefix. Nano is a prefix which is equal to 10 power minus 9. Whereas B. 1 microsecond is equal to how many seconds? 1 microsecond. Children, micro is equal to 10 power minus 6. So it is 10 power minus 6 seconds. C. 1 mean solar day is equal to how many seconds? 1 mean solar day. I can write like this, MSD. Children, as I told you that MSD means what? Not a Mahendra Singh Dhoni. It is mean solar day, which is equal to 86,400 seconds. 86,400 seconds. Last one. 1 year is equal to how many seconds? So children, 1 year is equal to 3.15 into 10 to the power of 7 seconds. Here you may get a one doubt. Sir, year means should we take a leap year? It's not that. Just normal year. 365 into 24 into 60 into 60. If you can do it, you will get 3.15 into 10 power 7 seconds. Now, question number 25. Here it is like, multiple choice. Question number 25 is a multiple choice. Name the physical quantities which are measured in the following units. Sorry, it's not a multiple choice. So, A, B, C, D, again 4 questions are there, we have to tell. So, here A is given to children. A is U. Children, so which physical quantity is measured in U? U means you may get a one doubt children. Actually, U is nothing but AMU. AMU. So, AMU only actually we can express as a U. Okay, children. So, AMU is what children? Unit of mass. It is a unit of mass. Now, B. So, it is given LY. Children, LY also don't get confused. LY means light year is used to measure the distance. That is the length. Distance, or you can write length. Actually, writing length is perfect. Length. C. NS. NS for D children? NS. NS is what? Nanosecond. NS is for what? Nanosecond, equal to 10 power minus 9 seconds. So, which is time. Which is actually time. Next, D. NM is given. NM. Nanometer. NM is given. It is a nanometer. Nanometer is again length only. Nanometer again it is length only. Okay, copy it. Yeah. Next, question number 26. It's very, very important. Write the derived units of the following quantities. Here 4 quantities are given. Question number 26A. Question number 26A. First one is speed, dear children. So, speed. Children, if you want to write the derived units, first you should know the formula. So, speed is equal to, there is a distance by time. This is nothing but length only. So, length is measured in meter. Time is measured in second. So, its unit is meter per second. That is how actually we have to write. B. Force. So, children, force is equal to, already we discussed, force is equal to mass into acceleration. Mass is kg, acceleration is meter per second square, like this. Just you go back to the our video, you will get how we got actually kg meter per second square. This one we can call it as a Newton also. Okay, we can call it as a Newton. Now, next, C. It is work. Children, here work is equal to actually, work is equal to force into displacement. Displacement is nothing but what? Length only again. Force already we got here. So, this will be kg meter per second square into displacement is nothing but length. So, the S unit of length is meter. Meter. So, it is meter into meter, it will be meter square. So, this is kg meter square per second square. Okay. Now, D. So, last bit in the question number 26. Pressure. So, it is a pressure. Pressure. Children, pressure means during our work, whatever we feel, it's not that pressure, it's some mental pressure, it's not that actually. So, pressure is force per area. So, force already children, we have kg meter per second square. Yes or no? Yes. Kg meter per second square. But area is not a fundamental quantity. It is again length into breadth, that is meter into meter. So, what is the SI unit of area, children? It is a meter square. It is meter square. So, here this square meter gets cancelled. So, here we will get kg meter inverse. This can be taken to the numerator. M minus 1 it will become and S minus 2. So, kg M minus 1 and S minus 2. This is a SI units of speed, force, work, pressure. Of course, the derived units. Okay, just copy it. Now, next question number 20. Hope you have copied. Yes. Question number 27, dear children. Question number 27. Here what happened, if you can look into the question number 27, how are the following derived units are related to the fundamental units? Of course, derived units are given, like SI units of derived quantities are given. They are asking us how they are related to the fundamental units. So, question number 27. Question number 27A. A is Newton is given. Newton. Children, Newton is a unit of what? Force. So just recall the formula of force. So if you can recall the formula of force, dear children, so it is F is equal to ma, and the mass can be written as kg, and the acceleration is meter per second. So this only we can call it the Newton. So here Newton is kg meter per second square, kg meter per second square. And next B, it is watt. Hey, watt means it's not a question, WHAT, watt, no, WATT, watt. So it is WATT. So it is actually a unit of what, children? Unit of pressure it is. Pressure? No, it's unit of power, unit of power. So let us recall the formula of power here. Children, we know that power is equal to work by time. Work by time. Children, before we wrote the what derived unit of work, right? What is that? Kg. Just recall. Kg meter square S minus 2. S minus 2. By second, you can take to the numerator. Take to the numerator. So it will be kg meter square S minus 3. So that you can write here. So it will be kg meter square S minus 3. Okay, children, fine. C. So it is C, joule. Children, here is joule. Joule is a SI unit of work. So we have to recall the work formula. So children, we know that work is equal to force into displacement. So force is already we have here, kg meter per second square. Kg meter per second square into the displacement is a meter. Meter into meter, it will be meter square. So it will be kg meter square per second square. That's it. It is a what actually joule is. Next D. Pascal it is. Pascal. Children, Pascal is a SI unit of pressure. Now it is a pressure. So we know that pressure is equal to force per area. Pressure is equal to force per area. Force is here only kg meter S minus 2 per area is what is meter square it is. It is meter square. Square, this gets cancelled. So what do we get here? Kg m minus 1 S minus 2. So these are the actually how can we express Newton, watt, joule, Pascal in fundamental unit. Just you copy it. Question number 28, it's last question. Name the physical quantities related to the following units. So question number 28A. Children, kilometer square. Kilometer square, that is kilometer into kilometer, that is area. It is related to the area. No doubt about it. B. Newton. Children, it is given Newton. So Newton is related to the force. Newton is related to the force. And let us write C. C is joule. And D is Pascal. E is watt. E is watt. So children, can you try? Just what is like joule is a unit for which physical quantity, and Pascal is used to measure which physical quantity? Watt. Okay, for watt I will write it is power. It is power. It is. What you have to do it now? What is the answer for joule? So which physical quantity is measured in joule? Which physical quantity is measured in Pascal? Just pause the video and you must comment the answer. What is that? You have to comment it, children. Which physical quantity is measured in joule and which physical quantity is measured in Pascal? Okay, children, fine. Children, these are the conceptual questions from exercise 1A, that is units and measurements and experimentation. In the next class, dear children, we have few numericals. It might be very, very small, very, very important. Even some multiple choice questions also which we have. So in next video, we will be discussing the exercise 1A only, multiple choice questions, and followed by what, dear children? Followed by numericals. So we are going to discuss. Thank you so much. All the very best.